Here is a nice problem that was checked by viewer. Here's the following information. Our goal, we are going to determine n as a natural number satisfy this following equation. So we get this bunch of the terms all the way down until we get 2 to the n. So we are going to determine the exponent n. Okay, so the whole thing is a perfect square. Okay, what is the n? Is strictly superior than 20, 22. Okay, in fact this is very nice and tricky problem. So it seems hard problem to solve, but there is there is a special trick. Once you find the trick, the problem is going to be more easier to solve. Okay, by the way, don't forget to hit the subscribe button, support the channel, like and comments. So now let's jump into solution. So now I'm going to, since we get number 4 as a base for the most of the terms here, we have only the last term, which is the base 2. So we are going to transfer everything in terms of 2 as a base. Okay, now let's do that. So this one becomes 2 to the 20, 22 plus 2 to the 20, 24 plus 2 to the 26 plus number 1, which is 2 to the 20, 27 plus the other one, you get 2 to the 228, and then the last before last term, which is 2 to the 230 plus the last one, which is 2 to the n. Everything is a perfect square. So the nice thing here, we get the base 2 all the way down. So what to do before we get into the solution, we are going to check the parity of n. Okay, it's very important. So I'm going to reduce the equation to the mat 3. Okay, so if I'm going to do that, this one becomes -1, or let's put it as an even. This one -1 is an even to the even, but this one is an odd, -1 to the odd, plus -1 all to the even, plus -1 all to the even, plus -1 all to the n, which is a congruent. We know x squared is always a congruent to 0 or 1 mat 3. It's more simple. Okay, so we get this odd with this even is going to be cancelled out. I will be left with 1, 2, 3 even terms here. So which means I get 1 plus 1 plus 1, which is 3. So we get 3 plus or minus all to the -1 to the n. You know 3 is a congruent to 0, which is a congruent to -1 to the n, which is a congruent to 0 or 1 mat 3. It's more simple. We cannot get 0 since we got minus number 1 here, so which means n must be even. If n is even, this one is turned into 1 as a reminder. So we get 1 is a congruent to 1 mat 3. So finally n must be even. If n is even, I'm going to put it on this form, n equals to m. Now let's get rid of this one. Now we are not going to replace n with 2m. Now we need to make some factorization here. I'm going to take 2 to the 20, 22 as a common factor, since this is the smallest integer comparing with this bunch of these terms. Okay, since n is strictly superior than 20, 22. Okay, so we get the following. I get 20, I get 2 to the 22 factor 1 plus 2 square plus 2 to the 5th plus 2 to the 6th plus 2 to the 8th plus 2 to the n minus 20, 22, which equals a perfect square, x square. Okay, here is the thing. Let's call this one as a capital A. So we know GCD, we know the GCD of the power 2. Okay, and this capital A equals 1. Okay, because this one is a odd, this one is a power of 2. Okay, so which means this one is a perfect square Also, this one is a perfect square. Thus, 2 to the 222, which equals 2 to the 1, 0, 11 square, which equals a square. Also, this bunch of the terms capital A equals b square. Okay, we need to work on this one only. Okay, now if you calculate all these things here, this one equals 357. This one, since n was even and 2022 is even minus even is going to give us even in exponent. Let's replace this one with 2m prime like this. Okay, then I'm going to bring this number down here, so I get 357 plus 2 to the 2m prime, which equals b square, because it's a perfect square. Okay, now let's move over this term to the right, and they will have a difference of two squares. Then we are going to factor out on the form of the product. So I get the following. So we get 357, which equals b minus 2 to the m prime factor b plus 2 to the m prime. Okay, we know this 357 equals 3 is multiplied by 7 is multiplied and is multiplied by 17. Okay, this one. So now we are going to check case by case. Since this term is smaller than this term is going to take number 1 or 3 or 7 or 17. Okay, because this one 3 is multiplied by 7 is going to give us 21. So this one, none of the cases are worked here, except when this one equals 17, this one is 21. Let's solve that equation. So we get b minus 2 to the m prime, which equals 17. The other one, b plus 2 to the m prime equals 21. Because 17 is multiplied by 21 is going to give us 357. Okay, put this equation minus this equation, it simply is going to give us 2 to the m prime plus number 1, which equals 21 minus 17, which equals 4, which equals 2 square. Okay, thus m prime plus number 1 equals 2. Finally, m prime equals 1. If m prime equals 1, I'm going to replace it here, because so we get here 2m prime, which equals n minus 20, 22. So replacing m prime with number 1, so I get 2 equals n minus 20, 22. Thus, n equals 20, 24. Now we have determined the value of n, which is 20, 24. If you replace it into n here, it's going to give us a perfect square. Okay, now we have done this problem. Thank you for watching. I will see you next video. Bye.